Okay, hey, thanks so much. All right, well, my name is Michael Zaletel. I am the VP of Technology and Innovation at Productive Edge and also the Creative Director at Edge Experiential. I am a Xamarin MVP and a Microsoft MVP. I have developed over 100 apps for iOS and Android, also HoloLens and other platforms. And today I want to talk to you about combining the incredible frameworks of ARKit and ARCore in Xamarin.Forms for a cross-platform experience. The primary goal of this is really talking about situations where you already have a Xamarin.Forms app and you've built a lot of IP around that Xamarin.Forms app. Maybe you've got a lot of features and the client or yourself wants to add an augmented reality view to that app. And I think that would be the primary use case, where you need to be able to support augmented reality in some form going forward. So we'll just get into it. And please feel free to ask questions. And if I'm able, I'll answer them quickly. If not, we'll get answers after the broadcast. Okay, so just a quick background on Productive Edge. Productive Edge is a software consultancy in Chicago. I've got about 250 people and about 25 million a year in billings. So it's a pretty good size software consultancy, and they do a lot of different types of things. So they've been able to allow me to do this and spend the time to prepare for this. So I want to do a little shout out to them. Edge Experiential is their sister company, and they do augmented reality, VR, all those types of things. So we approach this both from an experiential design perspective as well as from a software development perspective. All right, so what are ARKit and ARCore? First of all, I want to say that they're very similar in nature to one another. They're actually just almost identical in terms of how they work, how they function, and they're what are called visual inertial odometry based frameworks, or AR applications. ARKit, of course, was announced and released by Apple at WWDC 2017, prior to Google answering back with ARCore. But it's important to note that Google had been working on Project Tango for almost 2 years prior, and really they had been essentially shooting higher. They were shooting for a higher bar. They wanted to use dedicated hardware with 2 cameras that would improve the tracking capability over distance and location, and Apple just went ahead and said, we're going to do this based on single camera. But basically, both frameworks function around the concepts of tracking. In other words, tracking what's happening with the camera and what's happening with the movement of the device. Scene understanding in terms of, how do we understand the light, the ambient light in the scene? How do we understand other factors that are making up the scene? Are there planes, horizontal planes, vertical planes, things like that? And then, of course, the rendering. So that information is fed typically to a dedicated renderer that can be used to render what you see on the screen, right? And keep it locked in physical space to the world. Now, I've done a lot of research on ARKit-based apps, which are right now obviously the most popular and famous. I mean, ARCore isn't really ready for commercial use. So ARKit is where the majority of the augmented reality action is happening. And I just wanted to bring a few of these to your attention in case you haven't heard of them or haven't seen them. It's really great to download these 6 apps and spend some time in them, understand how the user interface works, and just show them to family and friends, decide what you like best about them. But between these 6 apps, you pretty much can cover the variety, the gamut of what you would do in augmented reality on the smartphone. The first is Lego AR Studio, which you can see in the screenshot in the lower left. It's really pretty amazing how many polygons they're able to render on the screen and how much detail they're able to provide. So if you buy a Lego kit, for example, you can look up the Lego kit, put it there on your counter, and then be able to zoom in and out and look around. It's pretty fun. The most recent release, obviously, is kind of relevant to what we're talking about in that it's really just a feature of the StubHub app. So the StubHub app is obviously a much broader, more complex app with a lot of different views and a lot of different functions and capabilities that make the app great for purchasing tickets and looking up venues and events. But they decided to add something special for the upcoming Super Bowl game, and they've got an augmented reality view of the stadium, so you can kind of see where the different sections are, and that's a nice good example of how we would approach something like that. All right, so let's see. Again, feel free to answer any questions, and we'll try and get those as quickly as possible. There's a few other apps I just want to cover real quickly. Holo 8i is a really great app to download. What's different about that, if you can see in that middle picture, where there's this green screen environment and it's surrounded by cameras, they do something really unique. They're really one of the only ones in the world to be able to do this. They're able to basically capture a video performance in 360. So they're not just taking a volumetric capture of an individual standing still, like is often done maybe for a 3D printing of a person, but they're actually capturing a full performance and they're creating a 3D model out of that. And then in the Holo 8i app, you can actually place those 3D model holograms on your surfaces, scale them, spin them around, and even record with your friends or something. So that's really cool. BMW has a really great app. One of the things that's really amazing about that is you can experiment with the exterior and the interior and the wheels. Love that app. It also shows off this concept of world scale, where a model is defined as being a particular size and scale. And so once it's placed in the real world, it maintains that size and scale precisely. So in some cases, you want to be able to scale the model up and down. In some cases, you want to be able to fix it to what its actual size is. IKEA Place is another really good example here on the right, where you can take any of IKEA's furniture, any of their accessories, lamps, couches, chairs, tables, and put them in your own apartment or your own living room to see what they would look like before you would buy them. Really great job. They've got shadows, realistic shadows. And then Cage Junkyard, which you'd search for it by Transformers, Cage Junkyard. It's another really great example of what you can achieve on the smartphone hardware when you think about all that's happening. There's a lot of polygons in these scenes. It drops a transformer there, but it also drops this entire set. And then when you tap on the transformer, it turns into a car and then runs into the set and crashes everything and explodes. Really is the best example of what you can achieve. So if you're worried that your augmented reality idea may not be possible to render in real time on your given smartphone, if you're able to run Cage Junkyard, it'll show you what is possible, and then that's what you can strive for in terms of performance. So the question then, I saw a question posted online, which was, which framework should I learn? In other words, I want to get into augmented reality, but I'm not really sure which framework I want to learn. And my feeling is that you should learn them both, primarily because they're so similar to one another. The additional effort to learn them both is very small, and keeping track of the updates and the announcements and the releases and improvements that are going to come out of Apple and Google over the next couple of years will give you a huge head start and a big advantage when it comes to augmented reality. And these concepts generally run through to HoloLens development as well, and probably will to other platforms like Magic Leap. So these concepts are good to learn now. The frameworks are so similar to one another, it's good to understand them and understand their methods and properties, and also to understand what's different about them. Some people sometimes think of Xamarin.Forms as sort of a shortcut. I always have seen Xamarin.Forms as a power tool. the best Xamarin.Forms developers are developers who have developed for both iOS and Android separately, right? They've coded apps in Android Studio using Java. They've coded apps in Xcode using Swift or Objective-C, and now they're able to use their deep knowledge of both low-level frameworks on both platforms to basically accomplish anything they want in Xamarin.Forms. So although they'll certainly save time and save effort by creating things using all the great Xamarin.Forms controls, these great Xamarin.Forms developers are able to dip down into the native platforms, create custom renderers where they need to, custom controls where they need to, and really accomplish anything they want. And what we've seen, at least in our firm, we've built some of the biggest Xamarin.Forms applications in the world, actually. One of our Xamarin.Forms applications was awarded a Microsoft finalist, Partner of the Year finalist award in the mobile category last year, and that app was for Humana. But what we've seen is that we're literally utilizing half the developers. So if a typical project like that might require 8 developers, we can use 4. It's just important to note that those 4 developers really have to know Android and the Android frameworks. They really have to know iOS and the iOS frameworks. And then on top of that, they need to understand and know Xamarin.Forms. And this is what gives them the power to do anything the client wants. So as you dig into ARKit and ARCore, I just want to encourage you to learn the underlying methods, the properties, understand what's possible. But it's also good to just get your hands dirty right now and start experimenting within your apps and see what works and what doesn't work. Try something simple to begin with. We're just at the beginning phase of this, or the beginning edge of this, and the more you take time to learn it now and experiment with it now, the more knowledge and experience you're going to have when the time comes. And if you get really good at it and you really feel comfortable and confident working in an augmented reality environment, then you can always progress to HoloLens and Magic Leap development if you want to go something more complicated. So I want to sort of preface this. This is kind of a lot on one slide. I basically put this up for those of you who want to just take a screenshot. We won't go through all this, but in preparing for this and asking some other Xamarin developers on our team to set up their environments for running ARCore and ARKit in Visual Studio, we found some issues. One small issue that really held up, one of our people, took them like 6 or 7 hours to solve this problem, is that you need to clone the Xamarin components from GitHub, the entire thing, because it's got the Android ARCore in it. In order to run the ARCore Xamarin.droid solution, you need to clone Xamarin components. Well, the problem is that on the root level of that directory, somebody committed a cake.packages.config that puts cake version at .17, and you're not able to build ARCore and Java GL, so you have to edit that package and edit it to 22 in order to navigate to the Android ARCore folder and run the build command on that. I have provided at the top a link to my GitHub AR.Forms sample, so all the code that we're going to talk about today. The project is there. You can download it and you'll be able to run it onto your iPhone, or if you have a Google Pixel, you should be able to run it there too. Although there's a little issue with Android that we'll talk about towards the end. But you will definitely be able to run it on an iPhone and build it to the iPhone and be able to play with the app and make changes to it. I'd ask if you make improvements or changes that you just try to commit those to GitHub, and let's just make that the best AR.Forms sample that we can. All right, so I won't go through these other pieces of this, but there's just some other little parts of getting that to work that you need to be able to follow. So take a screenshot of that if you want it.
So hey Michael, we got a quick question here from David. Are the AR APIs going to be available in CSharp natively soon? All right, so I think, David, you might want to follow up on what you mean by that, but I don't know if you have an answer, Michael.
I don't know the answer to that question. I see there's also another question from someone else, but it's just a hi. So I will follow up on that. But could you clarify, or maybe type in a clarification?
Yeah, because we are using ARCore and ARKit, using Xamarin bindings, using CSharp, right? So I think we're misunderstanding a bit. So we'll see if David can follow up on that.
Okay. All right. So now next I want to just talk about the key components of AR platforms. You know, if I was in a room with a large group, I know there's a lot of people watching this. If I was in a room with a large group, I might ask for a show of hands of who understands AR platforms in general, and maybe who's just here to see how it might work in Xamarin.Forms. But I'm going to go through this quickly. Really, there's 3 key components of any AR platform, and it involves motion tracking, it involves scene understanding, and it involves rendering. And visual odometry is the process of taking camera images, locating pixels because of features and highlights, and then comparing one camera image against another in sequence to determine, to try to determine where you are in space. And there's a good Wikipedia entry on visual odometry. What visual inertial odometry is, or VIO, is adding an IMU, or an inertial measurement unit, to the system, and that involves the accelerometer, the compass, the gyroscope, and the hardware basically that's in a smartphone that gives us 6 degrees of pose, basically X, Y, and Z axis, and rotation around X, Y, and Z, yaw, pitch, and roll, and so there's another Wikipedia entry there, but it's the combination of these two really. It's okay, I've got camera images coming in 30 frames a second, but I've also got motion data coming in 1,000 frames a second, or 1,000 hertz, right? And in visual inertial odometry, because these two systems are totally independent from one another, it uses a lot of math to basically self-correct one another, right? So if the camera is covered for just a moment, or if the camera is looking at a blank white wall, then it can fall back to the IMU data. If the phone is really still, or the phone is placed on a tripod, is not moving at all, then the camera data can be used in that moment. And so scene understanding is detecting planes. So there's some computer vision going on as far as not just detecting pixels and things, but trying to identify, to cast rays or cast points and identify planes in your scene, vertical and horizontal planes and other types of objects. And then there's this process of hit testing to really understand where should things stop and where should they start. And then light estimation is really important, because you want to take data from the camera frames and you want to ask yourself, how bright is it in my scene? In the case of the front-facing AR on iPhone 10, you've actually got light direction estimation, because it's actually using the picture of your face and between the two cameras on the front, and it actually can give you whether the light is coming from the left or from the right or from the top or something else. But we're not doing that here. But basically, light estimation is still important, because we want to render our objects with the right light. So if it's darker, we want our objects to be darker. If it's brighter, we want our objects to be brighter. And then we want rendering. So we have this constant stream of camera images coming in that sort of form our background. We have this tracking information, and we have scene understanding. We're going to send that all to our renderer to render the objects that are being overlaid on our camera view, hopefully to make them seem realistic. Okay, I was just checking to see if there's any questions. So we just talked about this a little bit, but here's some kind of intimidating charts and graphs. There's a great slide share down at the bottom if you want to take a screenshot of this and just type in that link. There's a great slide share that goes into the deep details of this for anybody that really wants to understand, but suffice to say, some crazy complex math. In my research for this, I found that there's really only about, I guess, 20 people in the entire world that are capable of building these systems. Obviously, they have a lot of people working for them, but the engineers that are leading these teams who really understand everything in depth, there's just not that many of them, and they have sort of moved around through different companies over the last 10 or 15 years. And so basically, though, what's happening is you're taking these camera frames, you're taking the data from the IMU, and you're calculating your position in space and the position of your camera towards the environment. All right, so checking to see if there's any questions here. Not seeing any right now, but we'll come back to that. All right, so I get asked, what are the advantages and disadvantages or pros and cons of both frameworks? The easy, quick answer is that Apple has a huge advantage because remember when Steve Jobs said that he wanted to control both software and hardware? Well, that has really paid off when it comes to augmented reality. It's so important to be able to control the entire ecosystem. In fact, people have been working on visual inertial odometry, AR-based systems for years, and several companies, startups, raised millions of dollars, back 5-6 years ago to try and make this work. And the problems they ran into is that the devices, the hardware just couldn't handle it. The accelerometers had too much error, and the gyroscopes had too much error, or the camera wasn't accurate enough or something, right? And so Apple has this huge advantage because they own the entire ecosystem. And they clearly started thinking about this back when they released the iPhone 6s. And I just want to emphasize that they thought about where they were going with this. So almost 3 generations back, they knew, and that's why when they announced the ARKit, they were able to go back to the iPhone 6s, because the iPhone 6s has, a 4K camera. It has a very reliable image stream. It has a really reliable and robust camera framework, AV foundation. But on top of that, it's got this incredibly cohesive integration of sensors, right? Accelerometer, gyroscope, compass, everything that Core Motion provides. But more importantly is calibration. And so what Apple does that very few others do is calibrate at various temperatures in the factory. And so they require a lot higher precision. So Google has an advantage when it comes to software. And I don't think anyone disputes that. They've been working on Tango for a lot longer. They had a 12 to 24 month lead. Of course, Apple bought a few companies that helped them out. But it's been stated by Matt Meisniks, which, again, there's a really great article that he wrote. I put the link down there if you want to take a screenshot of that. It's a really great read. It's a long read, but it really goes into a lot of detail. And he said Google could have easily shipped Tango's visual inertial odometry system in mass market Android phone over 12 months ago. They chose not to. If they had done this, ARKit would have looked like a catch-up instead of a breakthrough. So it's important to note that. I want to give Google the props, right? They were on this. They just didn't think to go ahead and simplify it. But also Google had the disadvantage of Android ecosystem fragmentation and lack of quality control and precision when it comes to the sensors and hardware that are necessary to make this actual technology work. Does anyone have any questions on that part? Okay. All right, so it's really, the other thing I want to say is that both companies, both Apple and Google, have made this really simple. So, if I scared you with these other slides and those graphs and charts and math and, calculus, it was to set you up to realize this stuff is really easy. I mean, it's probably the easiest thing I've ever done in app development. They've made the frameworks, they've abstracted things so well, they've made it so simple to work on that that you can literally just do this in minutes. Unfortunately, I mean, it's fortunate or unfortunate, but it's really great how quickly you can do this. And essentially, what you're really doing is just configuring. You're creating a session. Well, actually, you're creating your configuration first. Then you're creating your session, giving it your configuration. Then you have these frames that come out of that session, and the frames contain all this data that we've been talking about, the camera images and the IMU data. And then you have anchors that get set in your scene. And so ARKit has AR session configuration, ARCore has config, but basically it's just the same stuff. The key, so the key though is AR frame and ARcore.frame. again, if you notice, I mean, you're noticing the similarities in ARKit, it's AR frame, and ARCore, it's AR.core.frame. Really similar concepts. So in ARKit, you get what's called an AR camera object, which has the captured image, but it also has camera intrinsics. So you can, in other words, it has like the focal length, and it has your camera distortion, other things that you can adjust for, right? Then you also get tracking information in the AR frame. You get device orientation, location, and tracking information. Again, that 6 degrees that we were talking about. You get scene information, like features in the scene. You get light estimation, and so that's what you get in AR frame, is those 3 things. Then AR anchor, and on ARCore it's AR.core.anchor, gives you, these are important objects that give you real-world position and orientation in space. It's a relative or real-world position and orientation in space. And these are added or removed from your scene. You can either add them and remove them from your scene, or they can be used to represent a virtual content anchored to your physical environment. Or if you're using plane detection, they are automatically added to your session. Now, what you really get, though, is a list of anchors, right? So you're sort of asking for, give me the list of all the anchors. Now, I want to stop here and just mention that this is kind of starting to seem a little confusing or a little complicated. And in the case of ARCore, it kind of is, because in the case of ARCore, you have to deal with all this stuff. Now, there are some libraries and things that have made this simpler, but it's still kind of messy. The real differentiating factor with ARKit is SceneKit. And SceneKit, the integration with ARKit and SceneKit is so tight that there's actually an AR SceneKit, an AR SCN view, which is an inherited SceneKit view that combined with an AR session, and it basically gives you all this. It takes all this away from you. You don't have to even think about this stuff, because the AR SCN object just basically transmits all this tracking information, this camera information, camera intrinsic, scene understanding, light estimation, and everything, and just hands it to SceneKit, and SceneKit handles all the rendering and everything else. So in the case of ARKit, Apple's made it really, really, really simple, because you use SceneKit. Now, there is an option on ARKit on Apple, on iOS, to use Metal or Unity or Unreal or something. But if you use Metal, then you're kind of dealing with it at the bare bones. You're getting these getting these frame objects yourself. You're dealing with the information that's inside of them. You're getting the scene understanding information. You're managing all this, and you're sending it to your own rendering pipeline, which gets a lot more complicated. All right, so if anyone has any questions, let me know. I'll go next. All right, so creating an AR session in Swift is really easy. I'm just going to go over this quickly. I know we're here to talk about Xamarin, but I just want to show you how simple it is. Again, I really believe that being a Xamarin.Forms developer, being a great Xamarin.Forms developer, is about getting into Xcode, playing around in Swift, understanding the native frameworks. It's about getting into Android Studio, playing around with the Android frameworks and with Java, and understanding it, and then taking that knowledge back into building a cohesive Xamarin.Forms application that can dip into these native frameworks. So really, really what you're doing is and we're just going to talk about the yellow parts here, but you're really, just like we mentioned, you're creating a configuration. In this case, an AR world tracking configuration. There's different types of configurations. Configuration.plane detection, you're setting up what your plane detection is. This is actually ARKit 1.5 feature, which right now we're just doing horizontal. So normally this would be just horizontal. But in ARKit 1.5, which Apple just announced this last week as a part of iOS 11.3, they are now supporting vertical plane detection. And then you just basically create your session and you give it your configuration. It's that simple. Now, under the hood, I want to make it clear that not only is ARKit using SceneKit and the AR SCN view, but under the hood, when you create the session, Apple's dipping into AV Foundation. They're creating an AV capture session for you. they're dipping into CM Motion Manager, they're creating a core motion session for you, and all that's happening, and it's just giving you back these AR frames, which you don't even have to deal with the AR frames because those get fed into SceneKit. Again, the AR frame is a snapshot in time, including all the state of your session. And you can either call or pull those current frames, 30 frames a second, or you can set yourself as the delegate and just get them when new ones come in. And creating an AR session in Android Studio with Java, very similar. This is from the ARCore sample. Again, you're just setting up the basics, and you're creating your config, in this case an m default config, and then you're creating your session. And now you'll see all these render objects that we have to set up, and that's kind of goes back to what I was talking about with the difference between ARKit and ARCore. And we won't get into that right now. But suffice to say, there are some code and things out there that make this easier for you, but it's still being dealt with in a much lower level on ARCore. And creating an ARKit session in CSharp. This is from the Xamarin.iOS native sample. Again, you're creating your config, your AR world tracking configuration. You're setting up your plane detection to be horizontal, and then you're creating your scene view, and you're running the session with your config and your session options. So there's, again, that SCN view, that's what we were talking about, that really, really makes this simple. All right. Now, the way so I'm going to go through real quickly here how we brought this into Xamarin.Forms. The process is pretty simple, but basically there is an existing demo sample project for Xamarin.iOS that you can download. And interestingly enough, it kind of just shoves everything into the GameView controller class. So if you see here on the right, the ARKit sample project, everything is pretty much just in GameView controller.cs. And it's implementing UI view controller and IAR SCN view delegate, which again is that SceneKit combination of ARKit and SceneKit. Give me just 1 second and grab some water. Take a drink of water. Do you have any questions at this point? All right, so moving ahead. So to bring AR to Xamarin.Forms, there's a simple process that we walked through. I did provide, again, you can download this code on my GitHub, which I provided at the beginning, but I'm just going to walk through real quickly how we went about it. I did get help from some of our developers. So basically, though, we created a Xamarin.Forms solution with an AR page in the shared project and added references to Google.ARCore and Java GL. Starting with the iOS project, we created a custom view renderer in the iOS project, push that, and that gets pushed to the navigation stack. It uses an AR SCN view, again, that ARKit SceneKit combination view to drive the AR features. We inherited our renderer from page render and implemented IAR SCN view delegate interface, moved all the methods from the ARKit Xamarin.iOS game view controller to AR page render. So there's no real rocket science here. We basically just took that original Xamarin.iOS example and went through this process to move everything into our AR page render, our custom render. And we created a separate delegate class, which we used to create anchor nodes and receiving the updates. And we copied the project resources from Xamarin.iOS native project. All right, so going through some code here real quickly. We're going to jump into Visual Studio and actually run this project, and hopefully I can share my iPhone screen so you can see it running on my device, build and run from Visual Studio 2017 on Mac. But we just have some code snippets here to make it a little easier to go through this code. Again, I wasn't not sure if there's going to be a lot of questions, so I wanted to time this out. All right, so again, we just needed to create the AR page in our shared or PCL code and structure it as follows. really simple stuff, creating a public class AR page, which inherits content page, and then we create the view render in the iOS project by inheriting our render from page render and implementing the IARSCN view delegate interface in order to use an ARSCN view. Again, that's pretty simple. Again, let me know if you have questions going through here. Glad to answer them. We have enough time. And then we create a private ARSCN view property in this render. And before showing the AR screen to view to the user, we need to configure ARKit, and that's what's going on here. And we talked about this a little bit earlier. Same basic stuff. We're creating our config property, and we're creating a new AR world tracking configuration. We're setting up the plane detection property to be plane detection.horizontal, and we are setting up our session and running it with the configuration. Really, basically the same code as obviously as what we ran on for Xamarin.iOS native. And we add the viewDidLoad method from the sample game view controller. We are basically copying, again, this code is essentially copied from the Xamarin.iOS native. But I want to just talk about this part here a little bit. So I want you to understand the types of things you can deal with here. This is where we're setting our frame. This is where we're setting up our debug options. So we have this ARSCN debug options.show feature points and ARSCN debug options.show world origin. There's several other debug options. So if you just use autocomplete, you can kind of see what they are. You can turn those on and off. It just helps you to debug your scene. You know, one of them shows like dots on the planes that are detected. Others show an origin axis marker and those types of things. And then you can set whether a user in action is. And then we're going to add that subview to our page view. And we have to obviously add the supporting methods, like for handling touch events, touches began, for establishing our position in the world, for using for setting our anchors and doing hit testing, for defining. In this particular case, this demo, the reason they load these materials is because they're actually loading texture maps that render on a cube. So the demo is a cube, and there's like a Xamarin logo and a Microsoft logo, and these are set up as materials, and then the place cube method. But again, this stuff all comes from that Xamarin.iOS, and it's just been moved into our custom page renderer. Okay, so that's going to bring us to Visual Studio. 1 second here. Are you guys still able to? Someone can just say
yep.
Screen.
Yeah, so we can see Visual Studio right now.
All right. So I'm going to open the same project that I've put out there on my GitHub. So everybody's using the same thing if you've perhaps downloaded it. Okay, so this is our Zaman.Forms project. We have our shared code here. We have our Droid project and our iOS projects are here. Again, we needed to reference Google.ARCore and Java GL and go through those steps. Hopefully you screenshotted that, or we'll try and make these slides available too after the class. But basically those are important to be able to run the Android version of this. So if we look at our Zaman.Forms project, basically we just have, there's not a lot to it, right? There's this, we usually, we'll usually organize our projects by creating a controls folder and then create folders within the controls folder that define what the area of the project or the feature set that those controls are related to, just to help organize things. It's really a good idea. I mean, I've seen some Zaman.Forms projects that are really messy. We try to keep everything really organized, and so I recommend that highly. It makes it much easier for the next developer. But again, this is just creating this AR page, which when this code runs is going to dip into the iOS project in this case, and this is our AR page renderer that we just talked about. So there's quite a few things that we have to use, like Xamarin.Forms and SceneKit. SceneKit again goes back to what I was explaining before. ARKit, core graphics, foundation. There's just a lot going on here, and I also want to point out that when you're using ARKit and SceneKit, you're also using Core Motion. You're using AV Foundation. They've just really simplified all this for you. We talked a little bit about here under the debug options. If I were to comment these debug options, that would remove those things from the view. And we also talked a little bit about this, where we loaded these materials. So we're loading these materials. We are setting their properties. We are loading the actual PNG files that are going to be mapped, and then this is where we're placing the cube, and those materials get mapped onto the different sides of the cube. So that's kind of basically what's going on there. And then for the Android project, it's basically the same thing. I mean, we've got a AR page here, and again, this is got a lot of it's using a lot of different libraries, but it's basically the same kind of thing that's happening. We're creating our session. We are setting up our renders for plain rendering and things. And again, we won't go through all this code right now. What I'm going to do at the moment is I want to make sure that I want to see if I can get my iPhone sharing. One second. I had a little trouble with this earlier, so just bear with me for a second. See if I can get. Hello.
Hello there.
Hold on one second. Oh, there we go. Got it. Good. Can you guys see the iPhone as well?
We sure can.
Okay. So go up here, and I'm going to select my iPhone 10, and I've already got this set. For those of you who haven't worked in Xamarin.Forms much, there might be some people on this that haven't used Xamarin.Forms much, but basically the way it works here is you would set, if you're going to build to your Android device, you'd set that. If you're going to build your iOS device, you set that as a startup project. And then we're just going to run it. And let me see if I can have the best lighting in there. Let me see if I can find a space. That's good. Now I've got some things thrown on the floor because oddly enough, it kind of helps with scene detection. There's some objects that can track, so I've got like some paper. But you see the yellow dots. Can everybody see the yellow dots?
Yes.
That's the flame detection happening. And there's not a lot of points that are being detected, so this isn't necessarily the best environment. But if I tap, then I get that's where it places that cube. Okay? And I can kind of move around it, right? It's locking in my space. And again, those debug options that show that red cube and that show those dots can be turned on and off for debugging purposes. But again, sometimes it's helpful to have like some random objects I found for it to help the tracking. The tracking is actually a lot better right now just because those pieces of paper are on the ground. If I took those pieces of paper off the ground, then what would happen is the camera would struggle a little bit to try to understand the scene. So you want to have a lot of light. That's a really important point. You want to have a lot of light in your scene. the more variability you have. So this surface is a little better because it does have like different wood grain tiles. You want to have, hopefully some recognizable objects in your scene. That helps, and that's it. So you can go back to Visual Studio. All right. I'm going to stop this. So now I'm going to plug in my Google Pixel. 1 second. All right, and one of the reasons I wanted to run that here for you live on this guest lecture is so that you feel confident that when you download that code from my GitHub, that you'll be able to run it on your iPhone as well without problems. I know that's been a sore spot for me. Sometimes I'll watch these, I'll download the code, and it just doesn't work, and I get frustrated. So we really try to make that simple. Now I will say this, that we are having some difficulties with the Android version. Keep in mind that ARCore is pre-release, right? It's not publicly released. Or I believe it's a Samsung Galaxy S8 or an S8 Plus. Does anyone know if there are any other devices that are supported by ARCore besides those? I believe that's it. But all right, and we're going to set as a startup project our ARCore folder.
So
hey
Michael, you cut out real quick. We do have a question. Does it run on Pixel and Pixel 2?
Yes, Pixel and Pixel 2. I actually am using a Pixel right now. There are some things you need to do with the Pixel. You have to, here's the way I approach this stuff, guys. If I want to play with the newest stuff, right? What I do is I download the latest code from Apple for Xcode, and I plug my iPhone in, and I make sure that runs, right? And then I download the latest code from Google for Android Studio, and I plug my Pixel phone in, and I make sure that sample project runs. So before I even started trying to mess around with this stuff in Xamarin.Forms, I made sure that that I have the right device, I have the right iOS version, that my system is set up properly, that I'm not running on the wrong version of Xcode or something. It's really a good practice to try and eliminate any of those possibilities, right? And so, but if you go to if you search Google ARCore and you download their sample, they walk you through the steps that you have to do to set up your Pixel phone. There's a APK you have to install. I can't remember it right now exactly, but it's something like ARCore.something.apk, and you have to install that on your Google Pixel phone. You also have to set up. There's something else you have to set up. So just make sure that you've sort of gone through that Google-assisted Android Studio tutorial to make sure that the Google sample runs on your device first. And same thing with iOS, so that if you're in Xamarin and you're wondering why something's not working, you know that it's something going on in Visual Studio or with Xamarin as opposed to something that's going on at a lower level. All right, so now I can pick my, let's see here. Hold on. You can see here I've shown my Google Pixel. There was also some things I needed to do to download the API 27 or API 26, I think. So, just sort of walk through those things as well. And that's under Tools, SDK Manager, Android. Just make sure you have Android SDK Platform 27, I think it is, and this Android 8.0. All right, so I'm going to run this right now. It will build and it will install, but it may not work. I have no way to share my, unless anyone here on the call knows. Does anyone know how to, if you've got a MacBook Pro, do you know how to show the screen of a connected Pixel device? Is that even possible?
Yeah. I usually use a Chrome extension called Visor, VYSOR.
Okay.
But it's not built in to the Mac. There's also
okay.
Like the reflector too, so there's some software that can do it.
Okay. Well, I'm going to just build and run this right now anyway, just to show that we had to work out, again, remember I said that we had to download Xamarin, we had to clone Xamarin components, GitHub. We needed to change the cake.config to version 22. We needed to to build the libraries for ARKore and Java GL. And then we needed to set some configuration flags for those in the Droid project. Oh, I'm actually getting a warning now. I wasn't getting a warning before. Hold on 1 second. Now, what I suspect, while we're waiting for this, what I suspect, if there is errors here, they could be errors because I'm not referencing ARKore and Java GL properly with this new I moved the folder and maybe there's some sort of broken link. Yeah, I think that's probably what's happening. Let me see here. Actually, I haven't seen that warning before. That's definitely something I'll fix. I'm not going to fix it right now because I'm not sure what the problem is, but I will fix it and I will commit the updated fix to the GitHub. But it was compiling and running earlier, so I'm not sure. Again, as I said, I moved the code from one folder to another, and I may have broken the references.
Well, like you said, just it'll be in the GitHub repository later.
Yep.
So that's good.
So I think now is the time to just ask any final questions, and that's it. Hope everybody's enjoyed this. I know I enjoy talking about augmented reality. We work both. I work both in virtual reality and augmented reality. We do a lot of big experiential design things at observatories and stadiums where we do big VR attractions and augmented reality attractions. And I just love being able to do this stuff right on my own laptop, right on my own phone, just casually. And I think the future really is exciting. Again, ARKit 1.5 just came out last week, and some really great new features for vertical plane detection. Of course, Google's going to answer quickly in ARKore with the same. And it's going to be sort of an arms race. Again, I think Google's going to have a hard time playing catch up because they don't control their hardware ecosystem. So right now, Google's really pushing on their OEMs to implement a lot higher quality standards. And I think it's just going to improve smartphones overall. In a strange way, this augmented reality is sort of the killer app for the future smartphones, and it's going to make them much better. They're going to have better cameras. They're going to have better optics. They're going to have better, GPS and accelerometers and gyroscopes and all these sensors that are required. And they're going to have a lot tighter integration of those things. They're going to have a lot higher quality control and calibration at the factory at different temperatures. So this is going to benefit us all. It's going to take Google a little bit to catch up, but make no mistake, Google obviously Android has a lot wider install base, and so probably within a couple of years, I think we're going to see a lot of that difference disappear.
Yeah.
So if anybody has any questions,
I know I'm currently remodeling my kitchen, and I always keep thinking it'd be incredible if I could have an app that I could just point at various walls in the kitchen and see what it's going to look like before spending all that money. And I can't wait for the day where those things are commonplace to do things like that. I know IKEA's starting to get along those lines, but it's a huge market and a huge opportunity. And the fact that that Apple and Google have made this so accessible is, I think, amazing. We do have one question here. So are there any gotchas or things to be cautious of in regards to developing for iOS?
I think that the challenge I'm seeing, I've been watching the App Store since augmented reality apps could be released, and there wasn't the mass gold rush to the top. I mean, usually when a new phone comes out, a new iOS version comes out, there's always some app that takes advantage of that new platform, and those apps go to the top of the App Store. And that didn't happen here, right? So that was interesting. So I think there's, on the consumer side, consumers aren't really sure about this. They're kind of getting excited about it. But even right now, if you go to the App Store and look at the top 100 apps, there just aren't hardly any that are using this. So I think the main gotcha is, find a use case, find a purpose. There's a lot of sort of theoretical and esoterical ideas that could be implemented, but the important thing is to find something that actually works. We're working on a project where we're going to help a client visualize a construction project that's not yet done in conference room. So when they go out and do sales calls, they'll be able to put the model of the finished building in the middle of the table, and they'll, you know, using iPads, they'll be able to walk around and show the client and everything. So that's a really great use case, right? Or like Lego is a really great use case, or BMW, right? You can see a BMW in your driveway, color it, change it, configure it. You don't even have to go to the, you know, you don't have to drive to a dealer. If you live in a remote area, you can just put the car right in your driveway and start playing around with different options and see how it looks in your, you know, in your driveway. That's really cool. So I guess the main gotcha is just don't do something that's nobody's going to like, that's not going to be interesting, that is just for the sake of technology. Try to find a real use case that would make your client's app or your app all that much better, and you know, augment it with other things. Like, I don't think the app should just do augmented reality, right? It should do other things too, and the augmented reality should complement those things. As far as gotchas for iOS, I think it's going to get better, right? Now there's vertical plane detection, it's going to be better. But you want to make sure you have a lot of light in your scene, make sure clients understand that there needs to be a lot of light, make sure that you understand that you know, you have to have good, clear, visible surfaces. And so don't promise things like, you know, the types of things HoloLens can do, which is like walk around a big, you know, warehouse and sort of keep holograms floating in space perfectly, right? There needs to be good anchor points on the floors, vertical planes or horizontal planes. Any other questions?
It doesn't look like it. So Sean did mention also importing models into iOS can be a little tricky too. That's what Sean says.
Yeah, you know what? I want to spend just 1 minute on that. I've had nothing but trouble with, just in general, dealing with getting models into AR, and it's not just, you know, iOS ARKit or Android ARCore or whatever. There's just all these weird things. Like you want to use these, you've got to use these .obj files primarily. But the problem is all the great modelers and all the 3D animators we work with, they all, you know, work in 3D Max, 3D Studio Max or Maya. And the models they give us, there's problems with them. Either the axis point is wrong, right? You know, if you set it to rotate, it rotates around the wrong axis, or the textures don't map properly. So there are a lot of, you know, issues there. And that's what's even more impressive about like the BMW example or the Lego AR example. Obviously, they've nailed down the workflow for that. And, you know, I wish I had better suggestions and better ideas. One of the things we're doing is using some of the older, or, you know, not as popular 3D modeling programs. I think it's called Camtasia, I want to say, or maybe it's 4D, something 4D. I'll try to remember it and add it to the notes. But there is a modeling program that sort of natively works in the format that SceneKit expects. So as you're trying to work out these problems, it's not an ARKit problem, it's a SceneKit problem. So when you're trying to solve these problems and you're trying to figure out workflows for bringing 3D models in, game developers have been solving these problems for years with SceneKit apps and Unity apps. So I just would recommend that you look for solutions in that broader spectrum area. If you can, you know, bring models in and get them rendering properly in SceneKit, then they'll work fine in ARKit because it's using the SceneKit view.
So that kind of leads into one of the other questions. That's, do we need graphic design skills for ARKit, ARCore? I think I can answer that if you want to answer that one.
Well, I don't think you do, because I think you probably want to work with a designer in some way. But I think it's actually the issue is, if you've got a good model, right, you're just going to be the user is going to be placing that in the scene. You still need to have some design skills for creating your UI and how users are going to drop the objects in your scene and how they might change lighting or something like that. But it's a little different than your typical app, because the user is really just seeing a camera view into the real world, and they're dropping a model into the real world. And at that point, it's kind of like a camera app where you're, you know, yeah, you might have to have a record button or something, but there's not a whole lot of graphic design skills involved at that point. So if you've got a good modeler you work with, or you can download some free models from Google Warehouse, you can actually make something pretty cool that's fun to play with without a lot of graphic design skills. But I'd like to hear what you think too, Rob, on that point.
Yeah, I think it's just like creating any application, right? So as a developer, I'm very comfortable in C#. I can put together some UI. It might not look great, but having a designer working with you, I think, would be, like you said, very beneficial. And there's this, I would think, a separation of responsibilities. If you're talented enough to do both, that's great. But you could have a designer actually making the graphics and things like that. And as a Xamarin developer, as a C# developer, you can wire up all the ARKit and ARCode, actual C# code, and kind of separate those two things if you need to. Would be my my thought on it.
That's a really great answer, and it's true. And I think what we're finding is, as we add more and more layers of complexity, right now we're dealing with AR on top of everything else, right? So need for good teams is more important than ever, I think, because if you were a master of multiple subject areas 3 years ago, now it's even harder to be a master of multiple subject areas, because now you have to really understand 3D and 3D lighting and 3D rendering. You have to understand, just spatial design and those types of things. So I think if you can find someone to partner with, to work with, it's really a great combination. If you can find someone who's done 3D games or someone who's done 3D modeling and animation, they would make a great partner to put together a really great app that might, really blow the doors off the App Store. It's going to happen. Probably in the next year, there will be like the killer AR app that everybody wants to download, and it'll go to #1 because somebody will have thought of a great user experience and combine that with great design skills and great, programming and everything else to make it work.
All right, and there's another question. I think you already answered this, but how does one go about creating their own models? You mentioned some software, but how would you go about doing that?
So I think probably the best is Google SketchUp. You can get a free trial download of Google SketchUp, and it's really easy to use. And they have some really great tutorials. That's my recommendation. If you just want to get started in 3D modeling, Google SketchUp is like the simplest, easiest way, and the tutorials will show you how easy it is to start drawing objects and creating things. I even used Google SketchUp with my 3D printer to create cool stuff, and it's just really easy to delete, create a big square, for example, and cut a box out of the middle of it, or cut a hole out of the middle of it. So I think Google SketchUp would be a really great place to start. But the tutorials for it are going to show you like how to model those things. I think that would be my recommendation.
All right. So another question: how well does, I don't know if you have experimented with this, but how well does the machine learning kind of tie into ARKit? Was Sean's question.
Yeah, so I had a really long discussion with the top engineers of ARKit at WWC. I was very lucky to have like 3 of the top engineers of ARKit talk to me for like 20 or 30 minutes because I was so curious, asking so many questions. And I came to realize that ARKit is built on Core ML, and that's why those things came out at the same time, right? You've got machine learning, you've got the vision core, you got the vision APIs, you've got so there is a lot happening with trying to understand the scene, but there's a tight integration between Core ML, vision APIs, AV Foundation, Core Motion, Scene Kit that make all this work together. And I think what's going to happen really quickly is you could introduce so let's say plane detection or vertical plane detection. Those are really machine vision problems. But you could also, let's say you want to detect a logo in the scene. We actually did an AR project for a client, a big brand, one of the top brands in the world, where they wanted an app where when you pointed at their sign, it recognizes the sign and then shows a really cool ARKit-based 3D animation. And obviously that involved creating our own machine learning model with Keras and TensorFlow and importing that into the project, and then turning on. What happens when you get these frames, when you get these AR frames, you get a camera image with each frame 30 times a second. So you can take the pipeline, you can take that image object, the camera object that's in the frame, and send it to Core ML or to your machine vision detector and return back what's happening. and then trigger some sort of animation or trigger some sort of activity. So I think there's a lot of tight integration, and it's going to get even more. I mean, that's really where the cool stuff's going to be. Like let's say we want to detect our refrigerator and put stuff on our refrigerator. You've got two ways to do it. You can either try to figure out somebody's house and try to keep track of where everything is in their house, or you can just have a really good machine vision algorithm that can see and recognize a refrigerator, place an anchor point there, and then allow something to be placed on the refrigerator, like a Post-it note or something.
Fantastic. So I think that's all the questions. We're a little bit over time, which is fine. So for anybody who wants to come back and watch this again later, we are recording it. It'll be up on our website in the next couple days, and again, an exclusive to our Xamarin University subscribers. So thank you, everyone. And we have a couple more guest lectures coming up as well. So make sure to check back at our site. I'm constantly updating them, and if anybody has any other ideas of things you'd like to see during our guest lectures, please let me know. So again, just go to our site and look for Rob Gibbons on our time and on our team site, and I will reach out to people. So Michael, thank you so much. Augmented reality, as we've seen, it's going to be amazing. So hopefully everybody takes this and takes it away and starts looking for places where you can add it and add value to the apps that you're making. All right, so
thank you.
Thank you, everyone. And I hope everybody has a great day, and we will talk to you in the next guest lecture. Bye, everyone.